Hey guys, this is lesson 26 from Module 4 for 6th grade in Eureka Math. And there was no lesson summary here, so I just want to really spend a couple minutes on number 1 from the exercise and explain some of these big fancy words they're throwing at you. They're throwing at you the term tape diagrams, right? They're throwing at you the term algebraic methods and substitution to check your answer. And of course we have, if you remember for lesson 25, the word equations, which means we have our equal sign. And we are trying to solve each equation, and they're just going to be addition and subtraction for this lesson. So I want to just talk about a few different methods that I like, then point out my favorite, and you guys can pick and choose whichever one you want that makes sense to you. So let's give ourselves some space and get started here. My first method when I see something like this is whole part relationship. I recognize that addition is the combination of parts to equal a whole. So I know 15 is my whole, and I draw a number bond. That's what this is called. And I know b is a part, and therefore 9 is a part. And so since I understand what addition, subtraction, multiplication, and division are as operations, the combination or separation of parts from wholes, or two wholes, I know that if I add these parts together, I get my whole of 15. And therefore, to get a missing part, I have to subtract, to do the opposite. Subtraction is the taking of a whole, taking a part away, and finding the missing part. So I know that 15 minus 9 is going to give me my answer of 6, and therefore b equals 6. That's my particular favorite method. Now, they threw the tape diagram thing at you, so let's make a tape diagram. Remember, a tape diagram is when we use rectangles? Okay, and what we have here is, I'm going to do this a couple different ways. I'm going to say the whole thing is 15, which again, you have to recognize that that's your whole, right? I'm going to say that, to here is 9, and then here is b. So what I don't know is what b is, right? But what I can see is, in order to figure out b, if I already have a total of 15, don't I have to take this 9 away from 15 to find what is left? And so it's the same concept as this number bond. I just like this because I always see whole part relationship this way in my brain. It just, I put together my parts to get my whole. I take my whole and I subtract a part to get a missing part. So this is the tape diagram. This is the number bond. Both of them work. All right, and then algebraic ways, they might, you could rewrite this problem 3 different ways, right? If we were to think of this as a fact family, I could write it as 9 plus b equals 15, which doesn't really help me solve. But I could also write 15 minus b equals 9, which again doesn't really help me solve. And so my final question, 15 minus 9 equals b, is the question I would end up using, the expression I would use to solve, which I did over here, and I just explained here. But remember, we have the balancing of equations. So I'm going to rewrite the problem here with, let me change colors. Let's go with a purple. So I'm going to rewrite b plus 9 equals 15. And I'm going to draw my line and my balance beam, my little lever there at the equal sign. So they're perfectly balanced. Assume that's straight. Doesn't really look straight. And I want to get b by itself, right? The variable should be by itself equals something else. But right now it's touching a plus 9. So how do you get rid of the plus 9? To cancel out a plus 9, you do the opposite, which would be minus 9. What is plus 9 and minus 9 put together? It's 0. So these cancel out. But remember, I just really made my equation unbalanced. I have to do whatever I did here also over here. So that would be 15 minus 9. And again, I find myself right back in the same situation where I'm doing 15 minus 9 to get b. And therefore, b is going to equal 6. So whichever way makes sense to you, use. Use it consistently. Get really good at it. And then try and explore other ways. All right, let's check out the problem set. All right, remember to pause this as you go, or if you're just checking, hopefully you're already done with it and you're just checking, go ahead and let it play through, just check your answers. But remember to do the work on your own first and then use this as a self-assessment. Again, learning happens when you activate your brain and you try things on your own and struggle through it, not just when someone gives you answers and you write them down pretending like they're your own. That doesn't work. So an m minus 7 equals 17. This one asks us to use a tape diagram. So I'm going to go ahead and use a tape diagram. So m minus 7 equals 17 is my first problem, which means m is my whole. Remember, in my mind, even when I go to make a tape diagram, that's not what I see first. I see m on top, and then I see 7 and 17 as my parts. And that really helps me see that I'm going to end up adding those together to get my total, because I know in subtraction, when you subtract the whole number, right? Doesn't have to be a whole number, it could be a fraction, decimal, but the whole amount, right? The total, the whole goes first. And then you take something away, a part, and you get a part. So this is what the tape diagram would look like. And 17 plus 7 would be how you'd get m, which of course is going to be 24. So m equals 24. And you can check your answer with 24 minus 7, and yes, you get 17. Number 2. So for number 2, we have, wants us to solve it algebraically, it said, right up here. And all we're going to do for that is to either use our balance beam idea of balancing the equation. So I want to get n by itself to get rid of plus 14. I subtract 14, which will cancel that out, but I also have to subtract 14 from the other side. Again, this is where hopefully you see this picture in your head. 25 is your whole because this is an addition question, which means you're combining parts to equal a whole. And therefore, to find your missing part, you would subtract, right? To find missing parts, you subtract. And so 25 minus 14 gives you your answer, which of course is 11. N equals 11. To check your answer, you do 11 plus 14. And yes, you get 25. So for number 3, wants us to use a tape diagram and check our answer. So this is my tape diagram over here. I recognize in addition that when you're combining two things, those are the parts, and the whole is over here. So 18 is our total. 8 plus p would give me 18. Here's my number bond model, which means I would have to take a part away from 18 to find my missing part in p. So 18 minus 8 is my expression to solve, which of course is simply 10. So p equals 10 to check. I do 10 plus 8, and I get 18, so I am correct. I wasn't even recording that whole time. Oh man, I just did this whole problem. But you know what? I'm going to go through it again. So if we see g minus 62, subtraction, g is my whole. So I see g as at the top, and then these are my parts. To find a whole from parts, you have to add them. And so over here, balancing the equation is my other method. And to get g by itself, I have to get rid of minus 62, which would be with a plus 62, and do the same over here. So no matter what, I'm adding 14 and 62, which is going to be 76. Then I check it. 76 minus 62. 6 minus 2 is 4, and 7 minus 6 is 1, so it does work. Okay, I'm going to move a little bit quicker now that we've gone over those. So to check answers here, method of my choice, I see that I have a missing part, and therefore I'm subtracting. So I subtracted, I got 135. Done. All right, so on number 6, I really see the way they write these is very confusing. There's obviously a mistake. What they did is they took the p minus 21, and instead of adding 21 to cancel negative 21 or minus 21 out, they subtract 21 again. So the big mistake is right here on the minus 21. That should be plus 21. If it were a plus 21, and this were a plus 21, then the minus 21 and plus 21 would cancel out, leaving you p. But minus 21 minus 21 gives you minus 42, so that makes no sense. So in all reality, their mistake was subtracting 21 instead of adding 21. So just to clarify all that, what we really want to do is when we look at this original problem, and we'll zoom in so that we don't get distracted, we want to get p by itself. We have to cancel out this minus 21. And the only way to get rid of minus 21 is to do its opposite, which is plus 21. And we're going to do that to both sides. So plus 21 was the way to solve, not minus, which of course gives us p equals 55, right? P is supposed to equal 55. There you go. So for 7, you can see what they did is they're taking the plus 18 and they are canceling it out with minus 18. So far, so good. But remember, we had plus 18. To get rid of it was minus 18, and we have to do the same thing to each side, which means 22 has to be minus 18, and they did plus 18 right there. So that is their mistake. Bad. They should have subtracted 18, and 22 minus 18 is going to be 4. Not 40, which makes sense because 4 plus 18 equals 21 when you go back to the beginning. All right, and the last question, really just kind of a speed round. Let's see how well you know your facts and can figure out part-whole relationships. But if r plus 10, I'm on the first one here, if r plus 10 is 22, what plus 10 is 22? So in my mind, I know that it's a part plus 10 is 22, so my answer is less than 22. I'm going to do 22 minus 10, which is going to give me 12, and so I know poof, it's that one. Shabam. All right, what minus 15 is 5? So I know this has to be the whole. These are all whole numbers. This is going to be the biggest number, so I'm going to do 15 plus 5. It's going to be 20. And then what minus 18? Again, I'm going to add together 18 and 14, which is going to give me 32. And therefore, it is... Oh, that was a terrible line. My bad. And this one, I have a missing part. This is my total, my whole. So I'm going to subtract a part from 15, leaving me 10. R equals 10. There we go.